This is a question from GATE 2025. So here, in this question, a DC buck converter step down converter is given, and the capacitor current waveform is given for that converter, and the input voltage is given as 30 volt. We have to determine the inductor value, the value of the inductor used. So first of all, we have to understand what is the capacitor current here. So let's draw the buck converter. So inductor is placed with a load and a capacitor is connected across the load. Okay. So the inductor current splits into two parts. One is the load current and one is the capacitor current. Now, in any DC converter, the inductor current ranges between two limits. So if we plot the inductor waveform, so it will range between two limits like this. This is I minimum, I maximum. Charging period, this is the charging period, and this is the discharging period. Now, we know that the capacitor does not allow DC current or average current through it. That means the entire average current will go to the load. That means the I naught is nothing but the average component of IL, whereas the IC will carry the ripple. That means the entire inductor ripple will go to the capacitor ripple. That means we can see that the inductor ripple is equal to the capacitor ripple. Okay, so it is a very important conclusion. So if we split the inductor current into two parts, first is the average current, let's say this is I naught, and second will be the ripple current, that means the capacitor current. So the I max and I minimum will be shifted by I naught in the downward direction. So this will be our capacitor current IC. So IC plus I naught will become IL, just like this in this node. Okay. So now this IC waveform is essentially given in the question here. So, and we already deduced that the ripple in the capacitor current is same as the inductor current. So the ripple here is ripple in the capacitor current is .1 minus 0.1. So this is 0.2. Now, during turn on interval 0 to dt, the inductor charges, okay, and inductor charges. The voltage across the inductor in this period is, so this is, let's say, PS, and this is P naught, which is basically D PS. Okay, during turn on period, this will be turned on, and the voltage across the inductor will be PS minus P naught. Okay, so this is PS minus P naught. P naught is dVs, so dVs 1 minus dVs. So as the capacitor, the inductor is charging, so we can write here L di dt, and we can write L di as delta IL, okay, and the time period dt is basically dt minus 0, so we can write as dt and 1 minus d Vs. So L will become 1 minus d d Vs. We can write the t here as f, okay, and delta IL. So we determine the duty cycle and the frequency, and we can easily determine from the capacitor curve. So this is basically surging period 15 15, that means 30 by 50, alpha will be 30 by 50.6 alpha, or in this question we have written d, so d is 0.6, okay, and the entire waveform or the time period is 50 microsecond. So frequency is 1 by t and 1 by 50 microsecond is 20 kilohertz. Now putting every value here, 0.6, 0.4, Vs is given as 30 and F is 20 kilohertz and delta L is 0.2. If we calculate it, we'll get 1.8 millihenry, and which is the answer for this question. So this question looks easy, but this is not for directly formula based. We have to derive or plot the equation. So this is how this type of question is done. Thank you.